Morning.
Hey, Adam, good morning. Yeah, I just got your email and I will send the email addresses to Rick today, I think. Today? Yeah. I think I've got all the emails now. So I have, I think from this class, I have Adam, Obed, and Menguan, I think. Three people from 2B. Is it just 2B? Hang on just a sec. Okay. Let's see.
Morning.
Morning. All right. I have I have Eileen. Eileen, Obed, Colin, and Menguan. All right, 4 people from CS2B. Okay, that's cool.
Hey, Cameron, did Rick do the do a master's program? Is that right?
Where? Here or? Oh, yeah. So he, I think he did a master's at Georgia Tech. Georgia Tech. And in fact, I was talking to someone, well, actually this class, I think someone said Georgia Tech is one of the cheapest programs. Oh yeah, Adam, you said that, right?
Yeah.
Yeah. I remember that.
I'm really surprised. I thought it would be pretty expensive because I know, well, my daughter's cousin goes to Georgia Tech and I'm pretty sure she pays a lot of money. So I don't know what the story is. Maybe some programs are cheaper.
The online program is different. The online program is different from the on-campus program. The online program.
So why is the on-campus so much more expensive? I mean, it's the same thing, isn't it?
It is the same thing. Yeah. I think if you go on campus, the difference is they charge out-of-state tuition versus online tuition. I think Georgia Tech is allowed to charge a different price for their online degrees compared to their on-campus degrees.
So if you are a resident of Georgia, you get to pay the same amount as online students?
I think you pay in-state tuition, which might be a separate number in itself. The reason the online class is so cheap, I think, is because their profit model is where they allow many students in with the expectation most of them will not graduate. That's why a lot of students get in, and that's how they're able to offer it at a mass scale. So they're trying to basically, like, because there's no constraint on physical classrooms.
Oh, I see. So they're
take in as many as they can to make money. So it's cheaper per person.
I see. So they've taken a lot of students, but the standards are the same, so that a lot of students who are really not into it will not make it through. But they get the fees from everyone. I see. Okay. So yeah, that's a reasonable model. That's a reasonable model, right? Because it gives everyone an opportunity. Well, if you want to spend the money to find out whether you have the chops or not, yeah, it's fine, right? Because I think at Foothill, I'm pretty sure it costs a lot more to deliver online courses as opposed to on-campus courses, because for Foothill, I don't know if you've been to Foothill. It's a very beautiful campus and it's maintained very nicely on top of a hill and all. And I'm pretty sure there's a lot of money that goes into maintaining classrooms and all the fancy stuff they have in there. But in online classes, I'm just at home with a laptop, and we're having a fantastic, almost a face-to-face real class experience here, right? And because my CS2A is actually a face-to-face section this summer. And it's online, what's it called? Online synchronous. Yeah, online synchronous, that's Zoom. And I feel that, I'm having a much better time with my CS2A students on the Zoom format than when I used to teach it in person. Because when I used to teach it in person, I never even got to know the names of many of the students. I only got to know the names of the first few benchers. Right, and the people behind, I don't even get to look at their faces most of the time. They're, they're looking at their notebook, or they're, typing away, or they're watching YouTube videos for all I know, right? Because I have to walk around and find out, and I can't do that all the time. And so I didn't have this level of engagement in CS2A. 2B and 2C, okay. I think the students already get engaged by the time they're midway through 2B. They know they have to be engaged because by that time they're probably hooked. Right, because I think 2A you can do without being hooked into computer science, but by the middle of 2B I think most students will find that, wow, this is fantastic. I got to add that seasoning to my sandwich because I can't live without that anymore. And I think that kind of happens, that transition happens. And so I don't have to police the 2B and 2C classes that much, but 2A, I used to do a lot of work just to make sure that students understand or, paying attention in class. But now it is like, so it's such a piece of cake because, I'm here and I can look at all of you and I can, I can ask questions and everybody's a front bencher, right? Because that's the cool. Actually, that's what I told my son and my daughter too, when they first went to school. I was, giving them some tips and I said, the easiest way to learn without putting in a great deal of effort, because there are lots of people, you can learn the same thing, but this is what worked for me. And I said to them, well, whether you like it or not, just sit in the first bench. And because, you may think that I'm just sitting in the first bench and I'm having a tough time, but I'm not really, learning as much as the people in the back. But in my case, I found that sitting in the first bench, when I was a student, maybe just a tad uneasy because I don't know, because anytime the professor could walk around and look at what I'm doing or look at my notebook and see what I'm writing down and all. So I was on guard. And so it was uncomfortable for me to sit in the first bench, but that discomfort actually played a great part in my picking up the material, because I was a lot more engaged in class, making sure that I wasn't, the prof is not going to look in my notebook and say, what is this? This is not math, okay? and so I was really paying attention to everything he said, whereas this was not the case in my first 2 years of college education, where I used to sit in the back. Right, and I used to chat with people, and I used to share, stuff that is not even related to what the professor was saying, and I used to think, why is there easy stuff? I can pick it up later, right? But okay, it may be easy stuff, but easy stuff stops being easy when it piles up. when you have 15 easy things to master, they're not easy anymore. They become hard all of a sudden. But 15 easy things, one easy thing to master each day is actually easy. And that is a lesson that I had to learn the hard way. So I told my kids, sit in the front row, and I think my son followed that advice even when he went to college. Because one time when he was in a class, well, we went to San Diego to pick him up. It was the last class. And after that, we were going to come back to the Bay Area, and so I thought, well, you know what? Let's see how classes happen at UCSD. So I texted him, and he said, "This is the room I'm in, and you can just walk into any class." I'm pretty sure it's the same in UCLA too, right? Anyone, you don't have to be enrolled in a class. You can just walk in and sit in the back, right? So I walked into the class and sit in the back, and I sat in the back, and he was sitting in the front row. And I didn't ask him to sit in the front row, and so he was sitting in the front row, and maybe that's why he did well there. I don't know, but he would have done well anyway, I guess. But sitting in the front row is fantastic, and Zoom kind of forces all students to sit in the front row, which is so cool. So I'm gonna keep advocating that we should just teach more and more of Zoom courses. I know, even in math, right? Even in math, sometimes in Foothill, I walk past some classes where math, the professor is teaching some, math class. And I can see on the whiteboard, they have these, integral formulas and things like that. And she's trying to explain these things. But the door is in the back of the classroom. So I'm walking like this, and all the students, and the only screens I can look at are the people sitting in the back. And obviously everyone brings a laptop to class these days. And so I can look at the screen, and the teacher is teaching something, and then the students are watching something else completely unrelated. And then she has no way of finding out, right? Except until it comes to midterm too. So, even the assignments, I think many times are not set in such a way that you can force each student to cross each, hurdle at the right time. So many students tend to bunch up these assignments and do them all at the same time. It's a real pain, right? I stopped liking teaching like that after a while. That's why I just love these things, the modern way of teaching. So, all right, cool. So everybody here except Rohan is lined up to talk to Rick. So I will send Rick an email today. So, and if you have friends that want to join you, just let me know by the end of today. I think he'll be open to receiving more email addresses, but it depends on when he sends out the Zoom invite and all. Okay. All right. So I can see that you're all making great progress, and I'm very pleased to see that. And obviously, as Colin posted and Justin discovered, so Quest 7, you can actually pop Quest 7 without an efficient implementation. Because it turned out that I thought all along for the last 2 years, I thought everybody was doing the efficient implementation. But then after Justin passed that and he made a remark, that's when I went back and looked at my reference code, the testing code, and I found that there is a trophy for the efficient implementation, but it was hidden. And it was hidden in a way that you can actually miss it and not even notice. And so I put in more trophies now for the efficient implementation so that people will actually know, wow, this is like 29 trophies or 30 trophies here. I'm only getting 22. And I popped it so they'll know there's a lot more to be discovered there. So that's fun. And then Quest 8, just keep, so all right. So anyone, pass this message on. Anyone who is feeling discouraged at this point, maybe not you guys, okay, maybe some of your friends, after having struggled through 4, especially 4, because some people find 4 hard, 2, 3, 4. They just let them know that they don't have a lot more to struggle, okay? So they only need to struggle for maybe until Quest 8, okay? And Quest 8 is the last struggly kind of quest you'll have to do. Quest 9 will actually be an absolute pleasure for you to do, I think, right? There is not going to be any complex conceptual things that you need to learn in Quest 9. All of that stops with Quest 8. And then we'll resume again in 2C, but that will be heavy duty. Yeah, so I highly recommend that you pass this message on to anyone who is thinking of, okay, I'm just going to take a pass. There are lots of people, right, who say, oh, I've done Quest 6 and the rest of it, I'm just going to do it, at my pace. And maybe if I don't make it, that's fine. But let them know, please don't do that, because Quest 8 is the last difficult one in 2B. And after that, you are like totally set for 2C, I think. Anyway, well, yeah, I can just hand over to you guys right now if you want to start your conversation. That's fantastic. Okay, and I see that there are now. I think Mengyuan, you are already in. Well, actually, Colin has finished Quest 8, so he should be able to offer tips on Quest 8. Colin, you've finished Quest 8, I think, right? Because
yes, can you hear me?
Yeah, I can hear you.
Yeah, I have.
Okay, good. All right, so there are people who can help you with all the all the way. But if any of you have any questions, you should ask. Call me. Right, I'm just going to be here. Call me and I'll help you out. And again, take this chance to have an incredible discussion that you can hopefully TikTok. Right, you can take clips and TikTok it. And maybe TikTok will have a channel later on. 2 years down the line, there's a TikTok channel for C++. Okay, and it's all they're highly populated by CS2B students or the 2B ABC students from Foothill started it off. So that would be really super duper fun. Okay, all right, cool, great. No other questions for me. I can just turn the laptop around to face the garden, and you guys can continue your your table talk. What do we call it? Talk show rehearsals.
No.
Yeah, everybody okay? Thank you. You had your hand up at some point.
I don't have one question for you, I think.
Okay. All right, cool. Great. I'm going to leave you guys in your hands, and let me know. Just call out to me, okay? Just say Anand or Professor, and I'll be back. All right, it's being recorded, so I'll post it later.
How is everyone doing this morning?
Actually, I'm in the evening.
What?
Yeah, because I'm in China. 1 a.m.
That's the morning. 1 a.m.
Yeah,
is the morning,
still
right?
early
So
morning.
it's still a good morning.
Yeah.
Hey, what part of China are you in? Like generally?
Beijing, you
Oh, really?
know, internet. Yeah.
Wow. How big is Beijing now? How many people?
I don't know. I'm not good at geography, I think.
Okay.
Wait, why did you decide, how did you find this class? Like at this really, like this is like a random community college. How did you decide to enroll in this class?
Because I wanna apply for a master, CS master in United States, but actually I am graduate. My major for my undergraduate is sociology, so it's not related. So I wanna taught myself some courses.
Oh, and you wanted like the US transcripts.
Yeah,
That's cool.
because it's more formal. Yeah.
Mhm. Yeah,
Do you know where in the
Definitely.
US? Do you know what part of the US you want to move to? Like, if there's some city or state that you want to go to in particular?
I want to go to California, but it's
Yeah,
so
there we
difficult.
go.
I mean, this class will transfer for UC credit, so you're already on the right track.
Great.
For the
But I
class,
think it's
oh,
transferred for can be transferred to undergraduate degree, right? But I
Mhm.
want to pursue a master degree.
but it's still helpful to have, if you pursue a master's, there's some courses that will require you to have finished like prerequisite courses. For
Yeah,
example, if you
yeah.
want to take computer science master's at UCLA, you still need some of the lower division undergraduate courses, and this will transfer. So
Yeah.
it's
Yeah,
a good.
Great.
I wonder if 2C will count for the data algorithms requirements. I don't know. Are you gonna take
That's
2C?
usually an upper division. The
That's what I
algorithms
was
class
thinking,
is
yeah.
usually upper division, so I don't think it will transfer.
Yeah.
But Quest 7, I need to like get up to speed on the Reddit, but did anyone figure out the stickman thing? Like, 'cause my
Actually,
stickman is,
I have a question for the 8 quest. Oh, you have a question for the 7 quest? Oh, you can go on.
yeah.
I didn't
Oh,
hear
yeah.
it clearly.
I just wanted to see like if anyone got the stickman actually working, because I'm getting I got like off by 1 errors, and I just like I just like put as many permutations of different data types as possible, but I'm still not getting it. So are you guys just keeping it as size T?
Are you checking if h is equal to 1 and h is equal to 0?
Yeah, I
Alright,
am.
Yeah.
I have those covered.
Rohan, did you pass the stickman
Yeah,
test?
yeah, I did.
So it's possible.
Yeah.
I feel like I copied it exactly as it was written, and his arm is like pretty deformed. So
Yeah, I mean, in my opinion, my
I
stickman
don't
is
know if
very
they're wrong.
pretty. My stickman is actually more symmetrical the way I did it. But I don't know how to get it to pass. I like, did you guys just leave the data types as is?
Yeah. Yeah, I am.
Oh my
So
gosh.
which steps do you stack in? The in-queue or the
Quest
dequeue?
11. Oh, no, this is quest 7. Stickman. 6.
No, this is
Oh,
quest
wait, this
6.
is
This is
6.
6.
Oh, sorry, I misnamed it. I'm the wrong
Also,
number.
Oh.
what like example are you losing or points on, or you're not allowed able to pass? Like he usually gives his test cases.
I mean, for the stickman drawing, he was just drawing random stickmen every time. Like I made a Reddit post a while ago. It's mainly just the right arm, and like I just sent it into the chat. So you guys just copied and pasted sort of what the inputs were and left it as is, and it worked.
Yeah.
Yeah, mostly.
I guess I'm just really unlucky because I did this for, I think there was another quest where this happened to me too.
11.
Professor, do you have any recommendations for this off by one error? Besides me just like spanning every single possible permutation?
Yeah, well, definitely not. Is definitely not scanning all the permutations. Like Mengyuan and Colin said, I think the best way is to just stay as close to the spec as possible. If you use the exact same code and then just fill in the missing values, it should work.
Because that's what I started with. I copied and pasted like x plus w over 2, y plus h over 2. I like copied that verbatim in the spec, and it still wasn't working. So
Okay, how
Maybe-
about this? You should not spend any more time on this now. But if you're still
Mhm.
stuck on this problem after the final exam, right after the final, let me know,
Mhm.
and I'll take a look at that code, and we can, we'll coordinate and fix this for you.
Okay.
Because you've got the
Sounds like a
password now,
plan.
you should move on.
Yeah, sounds good. It was just bothering me. It's like itchy. It's like when you're
I know,
really itchy.
I'm pretty sure it will bother you, right? So let it bother you until the final.
Okay, sounds good. Megan, you had a question on quest 8.
Yeah, I think for the draw function, I just line the 4 points together. I think just call 4 times the line function.
Yeah, that's what I did. It's okay. I'll deal with it after the final. Let's move on
And-
to something.
And we need to use the content variable to check whether the line can be printed out. I don't do so much more, just this.
Yeah, I'll just leave it alone. It's okay.
Mm,
Let's move on to another question you guys have.
So, so actually I have a question for the quest 8. There's some codes that professor gives us, but I don't understand the thing in the for loop, like the conditional things in the for loop. What's the meaning of the thing in the middle, like the steroid and str? I don't understand whether there is not operation things.
So I think technically in C++ in a for loop, you don't have to have anything in the middle value. So I think this is just a placeholder, because it's not making it. There's no statement being made. So I believe it's just like a placeholder. And in fact, you can like delete when you're writing a for loop, you can just put 2 semicolons together and it'll skip over the middle condition, for instance. So I think that's what it's doing. I don't know.
I don't have a good understanding of strings in C++, but I believe that the for loop, the middle condition is you keep iterating until the middle condition is false. And I believe the middle condition is false when the string pointer points to, I don't know if I'm saying this correctly, but I think we're using a string that has a the backslash zero. I forget what the symbol's called, like the null. Professor, I don't know if you can help me out here with what that character is called that like ends the string in like C and C++, but I think that's
Null the null bit.
yeah, I think then when you reach that, then the middle expression becomes false, so the loop stops because the string pointer transitions from being true for any like non-null character to a null character, which returns false. I explain that in a very like roundabout way, but I think it's just that any character except the null character is true, and then we get to the end and we get the null character, and the middle condition is false, so we stop.
I
Okay,
endorse
got it.
Colin's explanation. I think that's right.
Great.
Yeah, a dereference pointer becomes false at a null pointer.
Yeah.
So then
Yeah.
you're probably right about the termination character, whatever it is. Colin, did you finish quest 9? Is it as easy as you were saying?
Well, yes, you can make the last part, like, I don't know if you've seen the people like posting the photos. I think me and someone else posted like the photo, which is sort of like you create your own graph. And that's not really graded, I don't think, but you can sort of do that however you want, which could be pretty tough. But the other ones are pretty much just following the guidelines. It's nothing too complicated, just like making sure you didn't skip over some like detail that you missed. But yeah, I'd say it's pretty straightforward after quest 8. To be honest, I found quest 7 and quest 8 the most interesting because you get to focus more on like the data structures and their implementations rather than and sorry, I don't know how to pronounce your name. Is it Aileen?
Eileen, yeah.
Eileen, like you mentioned, you had some like off by 1 errors, and to be honest with you, I just skipped the last part of quest 6 after I struggled to get the stickman working because I didn't want to focus on the off by 1 errors. But quest 7 and quest 8 allow you to just focus on like the core knowledge, I guess, which is
Concepts.
pretty
Okay, I love
interesting.
that. I love
Yeah.
that. I hate
I think-
wasting my time on like, is there an end line? Is there a note? Like, is there a space or not a space? I get really itchy and I just want to like grab it because I'm like, it's right there.
yeah.
But you're right. I need to stop itching myself and try to get those to work.
I think in the syllabus it says as soon as you get the next password, you should like go forward and not spend too much time working out like the next mini quest.
Yeah, that's definitely the right approach. But sometimes, it's like you have an itch and you just need to scratch it. That's how it feels. But I'm gonna move on.
And do you guys get 29 points for the quest 7? I think I just got 26. I don't know how to get the 3 left.
I think yeah, he said it. You have to implement, I think it was DQ in the most efficient way.
Mm-hmm. Okay.
So it's how the spec specifies how you want to do it.
Have you submitted it in like the last few days? Because I originally got 26 and then he added the extra trophies and then I resubmitted it and I got 29. So maybe you could try.
I tried
submitting it.
that, but I am still 26.
Oh yeah.
Yeah.
Yeah. It must be something about the implementation of like NQ and DQ.
Okay, got it. Thank you.
Because was I talking to you on the subreddit about that? Or was that someone else about like, it must have been someone else about like the modulus operator. It takes a while to wrap your head around like the visualization of a circular buffer because the vector is not really circular. You just have to imagine that it is, which is tricky. But it's interesting once you get it. It's pretty cool.
Yeah. I just watched some YouTube videos to help me to think what's a queue like. Yeah. I don't understand the specs actually.
Yeah, that's what I usually do. I go on YouTube. I like hearing someone talk to me. So I usually just go on YouTube and I just click as many videos as needed to build an intuition. So sometimes like just one really good video, sometimes I just watch 10 and then I get it. I don't know how people learned with textbooks before YouTube. I am very Gen Z. YouTube is like my teacher, YouTube University. I got my degree from YouTube
University, yeah.
So the deadline, okay, so the final and then afterwards we can polish clay.
So when is our final exam?
Adam, our final is next Thursday. No, August 4th.
August 4th. Okay,
I'm
thank you.
saying Adam, just for your, because I remember you didn't remember the midterm.
So Adam, do you retake your midterm exam?
Yeah, fortunately I was able to
Great.
get another shot at it. Yeah.
So it opens on August 4th. Let me. Hold on. August 4th, 12 a.m. It opens at midnight, and then it closes in 24 hours. So don't miss your finals, guys.
Have you guys taken other CS classes at Foothill? Like online?
I was gonna take the Linux one in the fall. They have some cool
The operating
like
system, you mean?
no Linux CS30. They have like an entire Linux series on like Bash shell and just like it's like CS30A all the way through CS30E. And I think that's pretty cool because you can go really in depth in a lot of Linux stuff, and you need that for a lot of jobs.
Do you have a Linux computer? Because I was looking at like learning about it, but I'm like, how am I going to learn if I
So I think what you're
can you
supposed to
run it
do
on a
is
Mac like virtually somehow?
I mean, Mac has Unix, right?
It's
But
Unix, right? But can you run like a Linux operating system somehow?
you can put it in like a box. I think there's a way to do it. Like you can create like a
Virtual
operating
machine.
yeah, and then like keep it in a it's like a container basically. And you like keep it in the container and run in that.
Oh, that's cool.
But I have the same problem. I have a Windows. I don't want to break my. I was looking at like some horror stories online where people tried to run Linux on their computer, not in a container, and then they just destroyed their whole computer and had to reboot. Don't do that. Don't destroy your computer.
Yeah, I took a class where we installed Linux using like a Docker image. So class provided it, and then you're using the Linux command line, and it's really similar to the Mac command line, but yeah, it's easy to do, like no problems.
So what kind of computer system do you use? Windows or the Mac?
I'm in
OS?
Windows.
Yeah, I run Mac.
So what compiler do you use, Anna?
For me, what am I using right now? I'm using G++, I think.
G++. Okay, all right.
G++. I mean, to be honest, I'm using C-Lion, and I've said this like every meeting, but like it makes it so much easier on Mac anyway. Like, so with VS Code, I was like fighting with, setting up the compilers exactly and set up the configuration files. But C-Lion, if you have an EDU pass email, you can get a C-Lion license, and they do a very good job of making it like very stable, very easy, and so I just use like the default compiler settings basically, and everything's working well, and debugging is really straightforward. So I highly recommend C-Lion if you don't like your current IDE setup.
Yeah, I'm currently using Charcode, but it cannot like fold your code when it goes too long, and I must roll up or roll down. It's so inefficient, I think. So I'm looking for some compiler which can fold some of my code together.
Oh, are you talking about a compiler or like an editor?
Oh, editor, all right.
Oh yeah.
I cannot. Yeah.
I'm sure you could do it on C-Line because it's supposed to be pretty powerful. I know personally I use VS Code because I like to just use VS Code for everything. But I know you can do like folds there. I'm sure you could do it on C-Line.
Okay.
I just don't know how. Yeah.
Okay.
Yeah, people really like VS Code, so definitely solid choice. But for some reason, I can't get those like configuration files to work easily. I don't know. I feel like I'm always having to mess with them.
Mhm.
So, Colin, have you had any configuration problems? Like I just
Yeah, actually, it's extremely
annoying.
frustrating. I don't know what I
Right?
don't know. I don't actually have any idea what I'm doing. I just like would change stuff until it worked. And I sort of learned a little bit of like how to change the standard that it compiles.
Yep.
Like, 17 versus 20 or whatever. But other than that, I have no idea. I just like sort of mess with it until it works because the Google searches like aren't that helpful.
No, dude. I honestly, if you have any discontent with VS Code, do C-Line. It's like
No,
super buttery.
I something about it. I just really like using VS Code for like any language. I really like that idea. And like I tried
He's
to
married to VS Code. You can't break him up. You can't get him to divorce
Well,
it.
I tried to use Vim because everyone was like, oh, Vim's like super fast. And then I was like, what? Have you guys tried to use it? It's so crazy because you can't really use the mouse. You have to like move around with the keys. And it's just like, wow, this is such a steep learning curve that I don't think I can do it. So I just stuck with VS Code. But you guys should check that out. It's kind of interesting how it works.
Yeah, I keep downloading like Vim plugins to try because there's like there's like a C-Line Vim plugin, right? So if you want the Vim experience in C-Line, and
yeah.
it literally comes from a time when there were no mouses, right? So
yeah.
like,
So it's good to know, I guess, but like it takes me like 100 times longer to do anything.
Yeah, still.
But then people just like crap on you if you do anything but Vim. Oh, you like use VS Code, like
I know there's a popular like full-on website, not full website, but like a full-on interactive Vim tutorial website that everyone uses. So if you ever like really want to learn Vim, there's like it has like a virtual keyboard. It's showing you what to type at every moment and stuff. So if you ever really want to get into it, I think personally that'd be like how I try to learn because I've tried reading the manuals and doing like the built-in tutorial. I don't know, man. Rohan, do you use Vim?
Big time investment.
No, I don't. I use Visual Studio.
Do you guys have any other Quest discussions? Otherwise, I feel like we can maybe end this for one a bit early if there's nothing else to discuss.
What about the leak code problems?
Oh, do you guys want to do a leak code problem? I mean, how many problems have you guys done?
I think our Quest 8 is kind of a leak code question.
Yeah.
I mean, they're all kind of leak code questions.
I did a leak code where I thought a try was like the optimal solution because it was right after I did Quest 8. So I was like saw prefixes and I was like, oh, the solution must be a try. But then it turned out that like the optimal solution was way faster. And I felt really stupid. But it was cool to like try to, well, that was no pun intended, but I tried to implement a try and it worked, but it just was too slow. Yeah, but Quest 8 is pretty cool in that way.
Yeah, it was like pretty hard for me to appreciate what like how important a more efficient solution is until like I took a class where we're using like millions of data points or whatever, and then like, oh, this doesn't run. It's like
I'm sitting here for 10 minutes waiting for this function.
No. I'm talking hours. I took an algorithms course and like you're like running it overnight and like because the implementation is just like not good enough, even though it makes a lot of sense and like so.
One of my friends, Jim isn't here, but one of my friends who's also physics, his simulations take like 7 days, like 24 times like 160 something hours to run on a CPU that has huge RAM. So if your time complexity is bad, that's like that 1 week turns into 1 month easily. We take CPU for granted. It's like when they sent the man to the moon, it was like a couple kilobytes of data, I think.
Have you guys registered for any courses for the fall? Is the registration open? Like I got an email about it, maybe.
Yeah, I just registered for 2C.
Yeah,
Is
is
that
it
full?
online?
It's with Anon.
Is
So-
that course full? Because I
No,
don't
you
have
go-
time to register that.
What did you say?
Oh, I don't have time to register
You don't
that.
have your enrollment yet?
Yeah.
I don't think it's gonna fill up.
day.
I don't think it's gonna fill up.
Yeah.
And if it does, I feel most people drop because they're like, it's too hard. I don't think it's gonna fill up.
Yeah, and I think somewhere he said something like, if you finish 2B, like you're guaranteed, he'll make sure that you can take 2C. So
Mhm.
definitely contact him if like there's any problems. Because I also don't think I can enroll yet either. So I think I have to, same situation. Are there any other classes you're looking at taking? Any other CS math classes you're looking at taking in this fall?
I don't think so. I just want to take the 2C and one linear algebra course. Yeah, to fulfill my math background. I think it's also important.
Where are you taking linear algebra?
I forget the university's name. Because I'm also do some interns these days, so I'm too busy to do that. Do that course homework. So I just leave that alone.
Are there any hidden gem classes that you guys have taken at Foothill that you would recommend besides this one? Because I see like there's like this intro to cloud computing and network basics. But I don't know if there's like any really cool classes that you guys would recommend that you guys taught. So there's writing apps for Android.
Mhm.
No recommendations.
I've only taken CS the last class in this one, so I have no idea.
Is there a TikTok production class?
I doubt it.
We can get the
professors are too old.
we get the C++ TikTok going.
Is there any value in also learning Java or doing the like Java version of this class, you guys think? I mean, maybe professor would have a better answer for it.
My colleagues all recommend me to learn Java. They think Java is much more easier than the C++.
Okay,
I
but is
think
it
Java's
better?
kinda go ahead.
Oh no, I was just like, do they recommend it because it's valuable or because it's easier? Because I don't care if it's harder. I just want to know if it's valuable.
I think it's better for the web development. Yeah, and there's no pointers here, so they think it's also much easier to learn that. Yeah.
Colin, what do you think?
I had this question when I was looking at like which should I do Python or C++, the series for like ABC at Foothill. And this is before I like knew anything about C++. I had done like Python basic stuff. And the answer I found was pretty interesting. And I think it makes a lot of sense after exploring other languages now, is that the C++ track would be really good, especially in the algorithms and data structures, because in C++ you have to be more deliberate about your implementation, because you're dealing with like manual memory allocation and deallocation, versus Python, which sort of handles a lot for you. So in that sense, people were mentioning that you would probably learn more just because you'd struggle more with C++.
But what about Java?
I think Java and Python, they're not obviously not the same, but they're similar in the sense that they have like garbage collectors. They do a lot of memory management for you. And part of that is that they're less efficient, but part of it is also that you don't have to take care of as much yourself. So I think they're somewhat analogous in this case, where it's like Python, Java, and then like C++ in a separate category. But to be honest with you, I don't know that much about Java. All I know is it's just like somewhat analogous to Python.
Really? I didn't know that. I thought Java was closer to C++.
Well, yeah, well, maybe I'm just talking about stuff I don't know, but that's what I've read.
Yeah.
So I don't want to say that definitively. That's just what I've read.
Professor.
Hey, yeah. What is it? What's up?
We're trying, I was wondering if you could provide perspective on learning, like, because you teach the Java class too. I'm wondering, like, I'm just curious if there's any additional value in taking the Java ABC class series as well, or doing the quest maybe.
Are you
Like,
asking for a suggestion from me?
Yeah, or just like perspective on like Java versus C++.
Okay. All right. Here's what I think. Okay. And you should obviously ask other people and make your own decision. I think that every programmer should learn C++ as their first language, because when you later on learn Java or Python, you will know how to use the language properly. Because I know lots of programmers, right? So in the past, I've hired some Python programmers who say, I can do this thing, right? But then, and they can do it, but the architecture of their solution in Python is a whole lot less efficient than someone who also writes it in Python, but having programmed in C++ before. And you'll actually get a very, I think, just because of the incidents of the last few days, I think we have a very good example. Quest number 7. Quest number 7, if you do it the Python way, or if you did it the way that a non-C++ programmer thinks, and who doesn't know computer science proper, right? Who just learned to program in Python and put things together, they would not be able to get the efficiency points. But the queue will work. The queue will work. So the reason for that is because C++ forces you to think about not only what your logic is doing, but it also forces you to think about how your logic is going to be executed at the machine level. So you could say, go to the moon and come back, because it's one step for you. And Java lets you do that, and Python lets you do that. But you don't know, well, I just need a piece of moon rock for my cake, so go and get it, because it's just one statement. But a C++ programmer will never tell his bot, go and get me a moon rock because I need it for my cake, because they'll know that it's going to take a huge amount of time, right? So when I see these untrained the naive programmers program in Python or Java, they will use inefficient data structures in inefficient ways and get things done. But C++, because it takes you all the way to the electron, that's why it takes you all the way to the electrons. You can actually say, because I'm going to turn this bit, this particular bit, you can do that, right? You can actually say in your computer, you have, let's say you have 20 gigabytes of memory, 32 gigabytes of memory. That's 32 billion bytes of memory, right? And that is 32 times 8 individual bits. Yes. So that's almost, you're talking about 250, 250 billion bits, 250 individual billion bits inside of your computer. Now, you can actually, in a C++ program, say, in my RAM, I want to turn on and off a bit that is located in address, I don't know, some 5,703. And it's one bit, not even one byte. You can turn one bit on and off. And that level of freedom is, people say, you don't need that level of freedom. Yeah, okay, that's fine. You don't need the level of freedom. And I completely agree with that. But I think that not needing the level of freedom is different from not knowing what that freedom gives you. You need to know what it does and then say, I'm not going to use it. That's great. Yes, you can't say I'm not going to use it because I don't even understand how to do it. So that is why I think C++ is the first language people should learn. And after that, all the other languages, if you ask for my recommendation, don't enroll in any courses, because anyone who's mastered C++ can basically go to YouTube University like Eileen and say, okay, I'm going to learn all these other zillions of languages. But you go to Google and download the documentation of Go. It'll take you a couple of weeks. If you know C++, it'll just take you a couple of weeks to pick up any other language. Now, the advantage of Java and Python, Python is one end of the spectrum. C++ is the other end of the spectrum. Whereas they're not really ends at all, because C++ is very close to the end. The real end is actually machine code, right? Because you can write your instructions, and if you do computer architecture, you can write your entire program can be written on a notebook using ones and zeros, right? Yes, because you just need to translate everything down to assembler, and an assembler to machine code is just a mapping, one-to-one mapping. You don't need, right? There's a bijection there. So C++ is not quite there, but you have very close to assembler. So I say it's one end of the spectrum. The other end of the spectrum is where you're very far away from the machine, saying, you know what, there's a lot of stuff that I have to do in C++, which is really routine stuff, because after a while of programming in C++, you're going to say, well, you know what, I don't want to be allocating and deallocating memory all the time. It's a real pain, and it's taking me, I don't know, 2% of my total development time just to do all the memory stuff. And now, because it's so routine and easy for me, I don't want to do the memory stuff, but I know how to do it. That is the time when you say, okay, now I'm ready to offload the memory part of it to someone else. Because a good manager will only give out parts of the work to other people that they know how to do, right? They know how to do, but they don't have the time to put everything together. They'll find people to do the bits for them, and then because if they don't know how to do it, they'll have to put up with some shoddy deliverable from a report. Yes, because they won't be able to check it. They won't be able to do a code review properly and say, well, you should be using this implementation. Yes. So a good manager always only forms out work that they already know to do. But there are lots of bad managers out there who say, I just need the power. So I have this thing and I need lots of people to do this for me. So I'm going to break it up, and you do this, you do this, you do this. Okay. That is, and they'll deliver a shoddy product too, because they can check for quality. And I don't know where I was going with that, but so yeah, the point at which you say, all right, now I am so comfortable with memory management that I don't need to do all of it anymore. But I know, when I get it down to a point where from this point onwards, the memory management is going to be routine, because I know the exact dance that needs to happen there. I don't want to do the dance, so I'll call a system routine to do that dance for me. Yeah. So now C++ itself evolved out of C, because in C you have to do every single thing on your own. I remember back in the day I used to program in C. Everything, even memory allocation and deallocation, need to be done. So with C++ and objects, they introduced something really beautiful, and they said, well, you know what? You don't want to deal with the pain of memory management, but at the same time you want the power of C. So let's take care of the memory management for you in C itself. And they made that part of the C++ language, where what was I going with that? They introduced the STL containers and methods that you can hook into destructors. And so in Java, if you I don't know if there are Java programmers here, but there's no equivalent of a destructor. If you create an object, you can't destroy it willfully in Java, right? You can let it go out of scope and say, I'm not going to use it anymore. And then you can depend on the operating system. Well, it's not the operating system, it's a runtime engine, JRE. Because to use Java, you need two things. To use Java, to use a Java program written by someone else, you only need the JRE. Yes, this is Java runtime environment. So you download that, and it'll execute your Java bytecode for you. You got it done. But if you want to write a Java program, you need to create the Java bytecode yourself. And so you need to write it in some language that looks like C++, but you give it to a Java compiler, and it's going to take that and strip out all the comments and all the other beautiful things that you got in your program for human readability, and then translate every instruction into 1 byte, which is internal to Java. It's not, so it is the Java intermediate, the Java intermediate code, that the bytecode that is generated by the Java compiler is very similar to assembler code. At assembler code in machine code level, it's very similar, but the crucial difference between the two is that assembler code is tailored for individual architectures, right? So if you buy an 8088 computer or an Intel computer, you got a different instruction set. You go to Motorola, you got download a different instruction set. And these manufacturers, in a very capitalistic environment, they're competing with each other, and they're not really, they make it hard for people to understand what other people are doing, so they can copy it. That's like a stupid way to make progress. So they all have different instruction set, different things. You got to learn. Even though you know the concept, you need to learn multiple languages. That is a pain, isn't it? And but just so Java said, let me be the middleman here and solve this problem and say there's a million assemblers out there. There's a new assemblers coming out, new chipsets coming out every day. So what I'll do is I will create my own assembler language. Okay, it's going to be assembler, meaning it's going to be efficient as assembler. However, this is not the assembler language of Apple's, Apple chips or ARM or Intel. It's a different assembler language called bytecode, which belongs to Java. It's the Java universe assembler. However, we will produce another program called the JRE, which is Java runtime environment, which knows to speak assembler to talk to the individual CPU, right? Because then you only need to produce one JRE per architecture. So there's a JRE for Intel, there's a JRE for Microsoft, all these multiple JREs. So those JREs are all different. They're not compatible. Each of them speaks a different language on the other side where the CPU exists. But on this side, all of them speak Java bytecode. Yeah. And so Java said, in a brilliant stroke, they said, well, you know what we're going to do is that we'll generate bytecode, which is going to be universally understandable by JREs. And you can take them, JREs are simple programs, right? Because they don't have to do a great deal of things. They just need to interpret and execute. And you can write a JRE, in fact. If you do Java, C++, actually, Java compiler is written in C++, right? So if you can write a JRE much more easily than you can write a Java compiler. Any compiler runtime system. So JRE says, well, you know what? I can understand the Java bytecode, and it's the same bytecode whether you run it on a Windows machine or a Unix machine or an Apple machine or a phone. It's exactly the same bytecode. That is why, Android and all that, right? So you write a program on a PC, you can actually run the program using JRE on your PC. And then you can say, well, it's all working now. Now I can take the exact same bytecode compiled by the Java compiler on Eclipse on your PC, and you can take that bytecode and load it on your phone, and an Android phone. Because Android really, if you think about it, Android is really Linux, isn't it? Because once you dock your phone and you can squirrel in, it'd be basically the Linux terminal. It's a whole lot slower than what you'll get in the cloud or your laptop, but it's essentially a Linux terminal. So so they have a JRE for the Android, and that runs all the bytecode that you load into. So anyway, where I was going with that is Java is a halfway house between totally compiled languages. A compiled language like C++ says, give me your program written in a human like C++, I'm going to turn it into ones and zeros, which no human except von Neumann can understand. Okay, so it'll translate directly into the architecture for a very, very specific machine. So if you take a C++ program and compile it on a Windows machine, you cannot run that compiled code on a Mac machine after that. Right, even Windows machine, right? Even Windows machines, if they change, if they're running on a different architecture, you can run Windows on ARM too, right? So it won't run there because the instructions are different. So, however, Java said, that's the problem we're trying to overcome, and we'll say this bytecode you can run it on anything you want, because that thing will give you this midway house called a JRE, which can understand this. So what happens in Java is that your source program is not translated into the native machine code, but it's translated into a halfway house, which can eventually be translated into machine code at runtime. So because the translation happens at runtime, not at compile time. Whereas with C++, the entire translation happens at compile time. Bam, you get ones and zeros. Yeah. In Java and other languages, which is intermediate bytecode, you generate bytecode. So that is your .class file. When you compile a Java program, you generate a .class file. that contains the bytecode for, what that particular class does. And so still, so the compiled .class files you can't read because they're not human readable anymore. They can only be understood by the JRE, not even by the operating system or the CPU. Only the JRE can understand the Java bytecode. Now, but there is going to be a small amount of overhead, right? Because now, and by the way, that is not the reason why C++ programs are fast. Because people usually say that, well, C++ is fast because it doesn't need to do any interpretation at runtime. Everything is already in native format. But, really speaking, things are so fast these days that tiny interpretive loop, which is basically translating from one assembler to another, is basically a direct bijection. So there is no latency really there, a very tiny amount of latency. Most of the inefficiency comes from other features of C++ that programmers leverage in Java. So anyway, so the runtime system will JRE, that's your runtime system, not your operating system anymore, right? That will take your bytecode, compile it, and run it. So that happens in Java. So that's a 3-step process, 2 steps, 1, 2, 3, or whatever. With Python and PHP and all these other languages, it's one more step, right? It's like BASIC. I don't know if any of you have programmed this language called BASIC. So my first programming language was BASIC, okay? Because back in the day, my sister or someone had a computer that you would plug into a TV, right? And we didn't have a TV at home, so we had to go to a friend's house, and my friend had a TV, and then it's called a Z80. Zlux 80 or something like that, Z80, and it was a little box. It was a little box, and then you plug one end of it into the TV, and the TV becomes your screen, and no hard disk or anything. When you have a program, you have to connect a cassette tape recorder to the box, and your program will be translated by the box into a series of squeals, right? And the amplitude or whatever it is, it's modulated so that your program is saved on a cassette tape. I think it squeals because when you take the cassette tape and play it, you only hear squeals, right? So, but it's translated into ones and zeros stored on a cassette tape. So, but that, and then I asked, I found out how to code these. The language was called BASIC, and that was, and the thing I liked about BASIC was that it was an interpreted language. It did not require you to write something, compile it into native code, and then run it, which is what you have to do in C++. And a lot of people find that intimidating, but that is actually the simplest part and easy to get over, right? This 2-step process saying, well, I got source code, I got to compile it, and then I got to run it. Whereas in Python, I can just type the program and say, run it, bam, it runs. Yeah. So people say, that's why I like Python. That I think is a stupid thing to say, okay? Because the fact that you have to compile it is nothing at all. You just have to get over it. And once you get over it, you can see the full power of C++. Why should you let that wall stand between you and C++, saying, well, I'm not going to learn about C++ because I got to compile my code. So anyway, so Python went all the way, PHP and Python, and said, we're going to be pure interpreted languages, not bytecode interpreted. Java is bytecode interpreted. The interpreted meaning instructions are only translated into CPU instructions at runtime. Yeah, anything that you don't know, if the CPU does not know beforehand what it's going to do, then it's really interpreted. The next instruction needs to be translated, then I can understand it. Translate, understand. That's what happens with Java. So it is an interpreted language, regardless of what people tell you, right? People will say, no, Java is a compiled language because you take Java code and you can compile it. No, that is bullshit. You can compile it into some kind of intermediate language like assembler. This is Java bytecode, but at runtime, it's still going to be interpreted. It's going to be interpreted from, Java bytecode, not from English like C++, right? But still it's interpreted. So it is an interpreted language. Python is basically still interpreted, but it goes one step further and says, we're not even going to do bytecode, right? We're going to do bytecode essentially because, in the process of translating, if you do compiler design later on in your graduate studies, for example, you'll find out that one of the best ways, one of the most we have found, right? One of the ways we found that is easy to optimize code is to take the raw code of that the programmer writes, tokenize it, clean it up and everything, but not generate machine code directly. We will always generate intermediate code. That's called, there's many names for this intermediate code. That intermediate code is not really C++ or Java anymore. It is some intermediate representation, which is kind of designed in such a way that it makes certain optimizations easy to perform. So you can look at the intermediate code and say, now I'm going to optimize it by, taking this variable that's repeatedly calculated to the same value inside of a loop, right? So I'm going to take it out of the loop. So, and the compiler does all that for you automatically. This is simple optimizations. Even more complex optimizations, I find out whether this actually does something or not. And it's a whole lot of, that's why writing a compiler is much harder than doing the interpreter. And so what happens is that your Java program or C++ or Python program is going to be loaded into memory, and then the bytecode is going to be generated, just like in Java, everything. And the optimizer, the code optimizer, will also kick in, regardless of whether it's Python or Java. Or, it'd be stupid to run a Python program that's not been optimized. Yes. So the optimizer will kick in, except it's not kicking in on your code. It's kicking in on the intermediate code that's been generated in memory. You don't even see it. It's all in memory now. And so it'll kick in and optimize that. And from that optimized code is finally translated to the native architecture by the Python runtime system. And that gets run. But anyway, that is my guess. In fact, I'm just guessing these things based on what I've learned a long time ago in compiler design. Maybe they do it slightly differently these days. I haven't, taken the effort to stay up to date. But I think that's what ideally should happen. Well, no, ideally should happen. Ideally, mostly happens is that it goes to the intermediate stage, because intermediate is easier to optimize rather than, raw code. And so Python and PHP and all those JavaScript, and they said, go all the way, just write in English. No, not English, but it's going to be the case, right? In 10 or 15 years, people will be able to program in English. Well, a kind of disambiguated form of English or Chinese or whatever it is, right? Human languages. We will find ways in which, well, you know what? The whole idea behind a programming language is that human languages are ambiguous. Yes, because we say one thing, we could mean many things. So if you had a human servant, they'll say, well, did you actually want me to buy it from Trader Joe's or Safeway? Because it's slightly different. They could ask me that. Whereas with a computer, you got a robot, for example, you got to tell, go to Safeway, at this location, buy it for me. And so you got to spell it out. And so the whole idea behind programming languages is essentially just to say, we'll take human language, which actually works beautifully for communication, as we all know, right? And we're going to strip out everything that could potentially be ambiguous. Because if it doesn't have to be, but if it's potentially ambiguous, there's a chance that some programmer will use it and someone else will misunderstand it. Yes? So we're going to spend a lot of time just looking at human language and getting rid of everything that could potentially, be ambiguous. And now we're left with a subset of things that you can actually do and still carry out everything that, and we'll, and then we'll give, that's why, all these languages have very similar pronouns, like for loops, while for loops, right? And you go to any language, it's pretty much the same, except you change the paradigm completely, like Prolog, they're different. But most of the procedural languages that we look at today, they're all very similar because they're all very, in English. So suppose I go to Africa or India or China, it will pretty much be the same, except these tokens words will mean whatever they do in that particular locale. And it's all been distilled down. Now, I think what we'll find is that with the help of AI, we will find eventually that, taking natural language and going all the way to an artificial programming language, certainly gives us a lot of disambiguation. However, with AI, we've found we can actually we don't have to go that far. We can actually stop right here so that, what we say is still totally English-like or totally Chinese-like. I'm talking to Meng-Yuan right now. However, it is not ambiguous. Therefore, it can be translated. Yeah? Because if it's ambiguous, you can't translate, right? You have to have a bijection, essentially. Isn't it? Well, I don't know if it has to be bijection, but it certainly has to have a, one-to-one. Or you can have many-to-one. Yeah, you should, yeah, whatever. So what I mean is that, why am I using the word bijection? Someone used it recently in Reddit, and it kind of stuck in my mind. I don't know. Anyway, so yeah. So what was I saying? Gee, I got sidetracked.
Wait, I have a follow-up question.
Yeah, sure.
So C++, we're sort of talking about it as this it can communicate directly with memory, but if that is the goal, isn't C actually better than C++?
They're the same. They're exactly the same. They're exactly the same. the only thing that, well, that's what I was starting to say at that time, and I got sidetracked into some other discussion. C, you have to do everything on your own, right? Whereas in C++, this whole idea of destructors came about. And I said, Java didn't have destructors, and then we talked about Java. So the idea of having a destructor is really cool, because that allows me to, when you want some data structure that needs to be located on the heap, yes, not on your stack, because if it's in your stack, it will go automatically. Yeah, but sometimes you want data structures on the heap because they got to grow all the way to 8 terabytes or something like that, and you don't have that much of stack. So so I want a data structure that's going to be located on the stack, but I don't want to be able, I don't want to have the headache of allocating and deallocating that much memory. So then C++ says, well, because we have objects and we have destructors, we can do that for you, right? Because you know how to do that, and that's the only thing that needs to happen. So the constructor will allocate the memory and the destructor will deallocate the memory. And if you do resizes, and we'll do the allocation, deallocation for you, right? But you don't have to worry about memory management from now on. And the beauty of that is that when you use a C++ data structure, you'll know exactly when it's coming into scope, when it's going out of scope. You don't have to worry about the garbage collector kicking it at random screwy times. Yes? Because in Java, I don't know if you're Java programmers, and I've mentioned this to my C+ in my 2A class, is that it is very, very hard to force the garbage collector to come on at a time which is opportune for you, right? Because you may be serving ads, for example, or you're processing live data. And when you're processing live data, but at night, for example, between 2 and 3, maybe everybody's sleeping. And maybe that's the time when you should do some cleanup and things like that. We're not able to schedule. And so in the middle of some complex task, we get unpredictability because the garbage collector kicks in and everything grinds to a halt. And that kind of thing happens because we don't have control over it. But C++ says, okay, well, you know what? You don't have to not have control over it. You can have control over it because, you're essentially going to take exactly what you're doing in Java. You're going to do it here, except you're going to say, in addition, because I know how to do it so well that in addition to doing that, I can also do some memory management, right? So otherwise, you're saying, well, you know what? This is really already too hard for me. I don't want to do memory management too far on top of that. But C++ programmers could say, well, you know what? This algorithm is actually a piece of cake for me. Not like for other languages where they are struggling so much, they can't do memory on top of it. So now this inside out, you can just say, I'm just going to go do the memory management. Was that your question, Eileen?
I just wanted to understand so C++ can access the low, it's low, but then C is an even lower level language.
No, every C program is a C++ program. They're exactly the same. The only difference is that C++ supports this extra keyword called class. And in class, you can group things together and you can attach a function to an object. So by the way, everything you can do in C++, you can also do in C. And vice versa. Right? But so and C++ grew out of C in exactly the same way as other languages grew out of C++. Meaning that in C++, in C, for example, if I want to attach a function to a structure, which is what a method is. In C++, you create an object and you can have functions, methods attached to the object. Yes. So you can say this object got that method is invoked, and this object is automatically passed in as a parameter, a free parameter called this. Yeah. So you can operate on the object. So but you can do that in C. You can have a function and you can have a pointer to a function and you can stick that on an object or a structure, right? But and scope, the public and private, I don't know, good programmers don't really usually need that because good programmers are very disciplined and they know, right? If something is there, even though it's public, I'm not going to go touch it. And but if you don't have that discipline, then the compiler has your back for you. You tag it with public and private, then you accidentally touch something that's private, it'll tell you. So I don't think that's much of a big deal for C++. The big deal is that C programmers who are programming in C were doing exactly what C++ programmers do, taking methods, attaching them to structures and things like that. And they were doing that so many times. And they were doing exactly the same thing so many times that they all sat together at AT&T Bell Labs maybe, right? And they said, well, can we figure out a way in which these functions cannot just be automatically invoked on these structures? I said, okay, let's do something called a class. And then you make an object out of the class that'll have all these functions attached to it, and you don't have to mess around with function pointers, right? And C, I had to do function pointers. No, yeah, you don't do any function pointers here. Yes, C++ has this new concept called, methods. And even when you have to, and this thing called functors. I don't know, do you implement functors here? Or maybe you did in, I don't know. Oh yeah, you actually get to implement a functor in CS2C. Yeah, and that's all really cool. And yeah, again, I went off on a long-winded tangential answer to Eileen's simple question. But whatever it was, I hope I answered that.
While you're on the topic, I'm just curious, do you have any favorite new languages or opinions about where languages are headed? Like Golang is obviously very popular. Rust, built on C++, I believe, and then Julia in
Rust is
scientific
so
community.
cool. Sorry.
Is it? Yeah, I'd love to hear about it.
I
I don't know anything about it.
I learned it. I started learning it last week. It's so cool. But
What is it called?
I interrupted you. Sorry, Adam. Go ahead.
It's called Julia, is it?
Well, yeah, I think Julia came out of like MIT kind of scientific purposes, and then Rust is somehow built on C++. Is that right, Con?
I don't know if that's true. I don't know. I think it was actually sort of designed. A lot of the design of Rust is like sort of just saying C++ did this wrong. It's
right.
Actually, I've heard it's like almost defined in opposition to it in some ways, at least from what I can tell, just because it's so strict about like, no, we're not even gonna let you compile this because it's not safe. And the compiler is like super helpful. But maybe I just don't know. I'm not aware that it is written or like sourced from C, I guess.
Yeah, I'm very tempted to say something here. Whenever people say C++ or assembler got it wrong, I think what they mean is that they've got it wrong because people of a certain ability and less can't do it right. Because if you think about it, if you have machine code, if you know what you're doing, you can do it. Yes, you can program a Turing machine, using on an infinite paper tape. And that's exactly what a computer does. So if you know what you're doing, you can do it anywhere. Von Neumann can program in ones and zeros, apparently. Now, I don't know if it's apocryphal, but but when they say, well, you know what, assembler is all wrong, we need a language on top of assembler that is going to prevent you from doing wrong things. What that means is that, well, okay, only the experts can do it that way, so other people need a little bit of protection. And so they say, well, these things are off limit now. And, and so C++ is apparently hard. I didn't know that. Lots of people are saying C++ is hard. And say, well, C++ is hard. Okay, so there are people of ability that's not equipped to handle C++. And so for them, C++ is wrong. And so if the majority of people say, we can't handle C++, then the majority are going to say, C++ is wrong. But C++ is not wrong. It is just the limit at which someone gives up. That is my opinion, anyway.
And do you have any opinion on, excuse me, on Go? I think Go was created by Google engineers who kind of wanted the performance of C++, but just as portable, but with some other design decisions. Have you messed around with any of those new languages?
All right. Yeah. Actually, I haven't. Right. In fact, I don't know. I know C++, and I had to learn Python and PHP and Python and PHP. I think that's it to put the question thing together. And so I know these things, and I used to teach Java, so I know Java. But I'm not. It doesn't matter. I think that I'm not really on tabs. I'm not the right person to ask regarding what's the latest and greatest. However, Go is an exception because there was a past colleague of mine, and in fact, it was not even my colleague. He left SRI before I joined, and he went to Nuance, I think, when they spun off. Mitch, not Mitch. Maybe, yeah. So anyway, so he was living in Palo Alto 5 years ago. 5 years ago, maybe he's still there, in a yellow house, and that's right, very close to the JLS school. That my daughter went there. So one time I was there, and I had a lot of time. and I wandered over to Mitch's home. And he said, remember the speech recognition system at SRI, which is thousands and thousands of lines of C code, not C++, C code. I over the last couple of weeks I wanted to learn Go. So I re-implemented the whole thing in Go. You want to see, right? So he wrote the entire, including the digital signal processing and then the language modeling and everything. So I knew it was at least as powerful as C++. And he was actually raving about it, saying, "Wow, you know what? It's really cool. It's really nice and all." But he's not the kind of guy who says, I think, because most of the people I've worked with at SRI, they're not the people who bitch about languages like that. They'll say, "Well, I like that because here I don't have to do this so many times. The language does it for me." Not, and because he was raving about it, I think the one interpretation of what you were saying, that people were saying that Go does things right that C++ got wrong. No, I think what they're meaning is that for certain kinds of applications, or even the majority of applications, where you actually end up doing certain things in C++ very, very often, Go can take that off your plate. And they've identified some subset of operations like that and made it a whole lot easier in Go. But if I'd talked to him, he would have told me why he liked it. But I just took it for granted that there must be some redeeming feature there. So that's all I know, right? And that's why I was really curious when Colin mentioned Julia. Is Julia, is that the name of the language?
Oh, I don't believe I mentioned Julia. I must have misspoke. I was just talking about Rust.
Oh, Rust.
Yeah.
Someone mentioned
Rust.
Julia recently, and
I
I thought, wow, that's
Yeah, I was mentioning it. It's used for, as I said, like scientific computing. So it's kind of like as I understand it, like a much faster Python type language, but
like Fortran.
I have a friend who
I used to write Fortran programs, but I did engineering, and we had to learn programming at that time. This was in the 80s, and electrical engineering means you had to know Fortran, and so I learned Fortran and wrote Fortran programs. In fact, I should say I was forced to learn Fortran in many ways because the computer center at our university was air conditioned, and the rest of the campus wasn't, obviously. And in India, it was really hot. And so I used to just go to the computer center to stay cool, and everybody around me were punching code away. So I used to stick around longer and longer and start watching them, and then I got interested myself. So it was the heat that drove me to computers. If I hadn't discovered it myself later.
So if we want to learn how to write entire programs in C, do you think it would be really difficult for us if we only know C++?
No. Yeah. You don't. First of all, you don't have to write C. Okay. For today, really, the only reason you need to read C is legacy code, because C++ is actually C. It is just C. Every C program is a C++ program. And if it is a C program and a C++ programmer cannot understand the C program, that person is not a C programmer, right? Because C is a superset of C. So it's there, and nobody would program in C unless they absolutely had to. But really, it's a false distinction, because I can write a C++ program which is just main hello world, and that's also a C program, right? So 90% of the programs many programmers write to test things out and check things out, they're not even C++ programmers, even though once they've verified the concept, they'll say, oh, all right, now I'll implement an object or a sophisticated class for it. But just to test out an algorithm, you're going to create a main, stick a vector in there, and a public class. Who cares? You're going to just verify the thing works, and you can just do it. And where I was going with that is that it may not even be a C++ program. You're not consciously programming in C++. You're just doing whatever it is to test it out. And many of them are just C programs. So you already know C. In fact, at this point, you know C. Because if you complete CS2B's first quest, that's pointers. Yes? If you've completed the duck quest, you're already a master of C, because you know every single feature of C plus classes. because every single feature that is most of the features that are useful and used by professional programmers, it's all part of C++, and that's what you learn in CS2A. Essentially, control structures and data structures in C is not a good idea, right? Because everything is public and you don't have methods. You have to do it. You can do data structures in C after you become a seasoned computer scientist, knowing how to think like a computer scientist. Then you can go back to C and do anything you want. Technically, if you read Knuth, right? So the fundamental algorithms, the volumes, right? The huge. So even though they talk about some of the most subtle and beautiful algorithms, they're all written in assembler. Right? So not some popular assembler, it's an assembler of some fictitious machine he created called Mix. So, but everything is written in assembler. And so, but the idea there is that, don't fixate on a language. You just need to know some way of communicating the logic to you. And I'll have some, language independent logic, just this assembler called Mix. You understand that, then I can describe what this list is going to do. Right? And then that's enough for us to do some mathematical proofs saying, all right, this will terminate, that will not terminate. Yeah.
And how important do you think it is? How important do you think it is to study assembly in for some processor, just to get used to seeing things at that level? Do you think that's a huge advantage, or do you think C++ is close enough to the metal, so to speak?
All right, so it's definitely going to help to know how assemblers work, and even if it is you don't have to learn a particular architecture. For, let's say, if you want to learn the assembler for Pentium, or is one of the, I don't know what the latest Intel chip is, or ARM, and I think it is a waste of time and probably a misinvestment to say, I'm going to learn ARM so that I can get learn ARM assembly so that I can get a job as an ARM assembly programmer. That that would be I'm going to buy a lottery ticket and hope it wins. And rather the approach should be, I learn the logic behind any kind of assembly, and but then my market is like infinite fold. Are you Intel? Are you ARM? Are you some virtual machine that doesn't even have a physical CPU? But I know how assembly works, and I can just, if you have your own instruction set, I can just do that thing in my mind. So a much better way for any interview to, right, or in your resume, is never to put down specific things and saying, well, I know C++, or I know this particular package called Django. I don't even know what Django does, but it sounds like a fun name, at least you use in movies and all, right? So I know Django, or that is all bullshit. Okay, so what you want is a person who knows what's behind Django, or whatever, as I know how communication happens, and I know how to make it happen. And if you have a brand new Martian computer that speaks a new language, yeah, it's fine, but I know how it happens. You just tell me how to do it. And if it's like 5 more tokens I need to know, that's fine. Yeah, I'll learn it. I came all the way from India to China, here, and it didn't take me a long time. So it's just a language, right? It's a superficial structure. The deep structure is what takes a great deal of time to get into shape. Once the deep structure is there, it can prevent the non-good superficial structures from forming. And then you'll be able to fine tune what's presented to you, so that you only pick things out that are useful. But the core is bad, then you won't be able to tell which is good and which is bad, and so you'll just keep growing indiscriminately, which is the whole ball. You don't want to grow the whole ball. You just want a good core, and then the tendrils going in just the right directions. So I don't know if that's a good visualization, but I think that's one way I would see it. Sorry. How did we get? Yeah, well, I don't even know what
we were just talking about, we were comparing and contrasting languages, but I guess I can say I know C now. I didn't know that I knew C, so that's cool.
Yeah, all of you. I think it'll be there. Nobody will believe you if you say you don't know C. Right? So I think, yeah, C is, C already. So don't worry. And I think other languages, unless you need credits. Like Colin, he's also finished. You're in your final year, right? You're senior now, or you graduate already. Colin.
Sorry, you're asking me about if I've
graduated? Did you graduate already?
Oh no, I'm gonna graduate in the spring. Well, I'm sort of taking classes at Foothill to supplement my education at UCSB.
Yeah. I mean, it's a
Um,
lot cheaper, right? It's
Yeah,
only $150 a year, and I
Yeah.
know, it's a much bigger fees at UCSB and all.
Also, I know Isla Vista is very distracting, so
dude, yeah,
maybe it's easier to focus.
I'm trying to code, and it's like it was like 9 a.m. the other day, and my neighbor's like blasting music next door, and it's like, wow, I cannot focus at all. So it's like adds a layer of complexity. I guess I'll be able to work in like a complicated work environment, though. I can put that on my resume for the future.
Knows how to work in a complicated work environment. Yes. Yeah, that'll command a hefty premium for sure. But bottom line is, the more specific you are in your resume, the more constrained you are also. And a lot of people don't seem to know that. And you get resumes all the time from recruiters sometimes, right? And not anymore. I'm not, back in the day. I say, this person knows this, and they're the least likely hire. You want someone who knows the thing behind, and not specific things.
What do you
And
think?
also in
So
interviews. Yeah.
I have a mentor, and he has this very, very strong opinion. And I want to get your opinion on his very strong opinion. His opinion
Hey, hang on. Eileen, you're actually cutting out. Wait a sec. You're actually, I just maxed out, but it was very close to max before. You were cutting out.
Is it
Eileen, I
better?
can hear you. That's much better. Yeah.
I don't know what happened, but I have.
You're still cutting out. You're still cutting out. Hey, is Eileen cutting out for you guys also? That's much better. I can hear you now.
Okay. Wait. Adam and Colin and Megan, could you guys hear me before?
I can hear you. I can't see you anymore.
I turned it off because it made
Okay.
it worse. But my mentor told me that he has like very strong opinions on languages and software engineering career development. And he said, if you want to be a software engineer, you have to learn one language very well and only code in that one language for the first couple of years and become an expert in that language. But based off of what you said, that seems to contradict his advice. So what's your opinion?
No, why would it? I think it's one very good and practical way to do it. Learn one language really solidly does not mean just getting to get things done in that language, right? You're going to learn solidly. I mean, you have to know, even if I implement it in Python, I need to know exactly what the hell is going on. Should I use a dictionary or an array? Because both of those will do the job for you. So if you say, I know Python just because I can do it, so that's not what he means. What he means by learn it really solidly means, get to know how to do it easily first, but then also don't stop there and say, I know this language already. You need to go all the way. So I don't think there's any contradiction there. So he's saying, and that's a very valid track. So pick any language you want, go right in it, but don't stop there and call yourself saying, okay, now I've mastered 3A, 3B, 3C, so I now know Python. That is the wrong thing to say. So I've done 3A, 3B, 3C now, but I also know enough Python now to marinate for a bit and think about, ruminate on how it does things. Because unless you know how Python does things, you can't say I know Python, right? It's just like humans. Unless you know them, you don't know them. So you need to know not only how Python works, but you need to know how Python thinks. Then you know Python. And so, and that's, I think, what he means. You can check this with him. When he says get to know it well, means just don't get to know how it works, but also get to know how it thinks. And getting to know how it thinks is really, what also drives C++. So essentially what he's saying is that that core is what you understand, what you need to understand, but there's many ways you can learn it. So C++ is one way, which kind of forces you down a track where you can't, you got to learn it on day one. Or you can learn it with Java and Python, which will, set you up with enough to, earn a little bread and butter, while at the same time being wise enough to say, well, now that I've got my bread and butter, I'm set, right? So he said, no, I've chosen a path, but I'm going to go all the way in it. And so there's many ways in which you can find how things work. And C++ is one way that I recommend because, it puts a hard problem out of the way. You know, you got to master some fundamental things up front. Whereas in Python and Java, those fundamental things you still have to master. You got to do ABC. Okay, A is really hard. So in C++, you got to learn A, B, and C in that sequence. Whereas I think in Python, you still have to do ABC, but you could do CAB or BAC, right? But a lot of people will just do the C part or the first couple, and before they get to the A, which is hard, they'll say, I know how to do things, so I know the language. And and I find that even interviewers don't know how to tease it out. They don't know how to tell if the person knows how to work something or they know the thinking behind how it gets done, because that's what's important. And interviewers sometimes will basically say, if you observe the interview, they'll ask stupid ass questions. Like, you know, if a person knows how to use a toolkit or some particular transformation that is so common these days. And you know, problems out of lead code, you know, or Glassdoor or something like that. And but those kinds of things don't give much insight into how the programmer thinks. And even interviewers are, it's hard to find people. I think that's why I think one of the famous sayings attributed to Steve Jobs that I really like. When I heard that the first time, I thought that is the absolute right thing to say, right? Because only A people will hire other A people, right? If you're anything less than an A, you're never ever going to hire an A person, because that means your days as an A is numbered. Or, you know, if you're B in A's seat, you're never going to hire an A under you, because that A is going to eventually take over. So if a company has got to even sustain itself, not go downhill, right? Even sustaining is the only choice is to only hire A people. If you can't afford that, you should only have A people at the managerial levels. If the manager is a B person, you're screwed, because everyone under them is going to be less than B. Right? It's a natural tendency, isn't it? So I absolutely adored that statement and said, well, what a fantastic way to say that, right? So only A+ people will go for other A+ people. Everybody else will be just content to say, you know, I don't. And you know, how did that come about? But yeah, what I was saying is that it's essentially the same. You just have to get all the way through to tease out and understand. And Python and Java, the risk that many people don't know is that they're all the same, right? Everything lets you get the job done, whether it's Go or Python, everything lets you get the job done. And I think where Python and Java, I think I was about to say something clever and I forgot. Yeah, that's right. Okay, I remember. So the higher risk. Yeah. Okay, I got exactly what I want to say. If you want to hire a programmer, an engineer, you have a much safer bet as a company, as spending your money or whatever it is. If all of that is important to you, going for someone who knows how to program in C++, because rather than someone says, you know, I know Java, I know Python. No, right? Do you know C++? Then you have much more of my bandwidth. I'll look more into detail into what you know. And the reason I say that is because it's just like, you know, these days, someone goes to a very prestigious college, you can hire them with a higher risk, because, you know, or, you know, less risk for you, because the college has already pre-screened the candidate for you. Yes? Because it's hard to get into the college unless you're really good. So you don't have to put so much effort into interviewing someone who's already been pre-screened. So C++ for me is that kind of a screen. So if someone says, I know C++, I don't have to grill them as hard. But if someone says, I know Java or Python, yeah, okay, maybe you still know everything. Because I know someone back at, you know, my neighbor at SRI, he's like a Java whiz, okay? He did do anything and he's so passionate about Java. He didn't know a single word of C++, but he was, everything I could do, he could do too. Right, except he would do it in Eclipse. And I said, well, okay, everything is working now. You can translate to C++, it'll be faster. Okay, yeah, you can save the last few cycles. So, and he was working on kick-ass stuff too. And there was another engineer who apparently wrote the entire recognition system we had in Java. His name was John, I think. Yeah, so, and then he left for some reason. But so it's Java, everything you can do, right? So even signal processing and stuff like that. But the risk with hiring a Java programmer is that you got to be really solid. And so if you go to a manager that's really solid, they're going to expect, well, you know what, I'm going to have to drill down and find out all these details first before I can ask the really solid questions. Whereas if you know C++, then I can dive right into the solid questions. I get more time to get to know you, and we may make better decisions and things like that. With Java and Python, the risk is greater that someone could just come in through the door saying, I know these famous packages in Python, you know, for machine learning, or how to use NumPy, you know, but NumPy has been around for a long time. You know, the numerical recipes book in C++ and C. Essentially, all of those algorithms coded up in C++ with a Python interface. That's your NumPy. And yeah, so, but someone who knows that shouldn't be given any extra, you know, weight in interviews, but they tend to command a lot of respect, which is incorrect. And I think, in my opinion, because of people that don't know what they're looking for. They're just looking to fill, you know, fill up all the holes, whether they're square in a circle, like they don't care. They just need something and something. And they just, and that doesn't result in a pretty picture, I think. And so it takes longer to grill someone. Now, of course, I mean, that's why some of these big companies would probably say, you know, you use whatever language you want, but we want to go into the concepts. So I'm pretty sure you can go to Microsoft or somewhere, right? And then an interview question will be, you know, not, you know, code this in a language, but it will basically say, you know, use any language you want, but this is a problem to solve. And you can even, I'm pretty sure, right? My friends have seen, had interview candidates who coded just on the whiteboard and English, in English. Not even C++ or any language expected of them. They said, this is the problem, this is how I solve it, and I would use this thing here and this thing here and this thing here, and this will update it like that, and just arrows in English, and that's fine. And so it's at the end of the day, it's not even C++, right? So, and I think that's very important, and to just dive into the detail. And yeah, I think that's why big companies also do that and say, you know, it doesn't matter what language you know. If you don't know C++, it's fine. But it's okay if you know Java. And that is why I think there's also a lot of resentment in the Bay Area saying, I'm supposed to be a Java expert or Python expert. I've been 20 years programming in Java, but I don't get a job at, you know, XYZ. And it's because even though they know Java, that's not what the company expects, right? So it doesn't matter to us, even if you don't know Java. What we want to know is that this problem needs to be solved. And I don't care if you don't know any programming at all. Just tell me how you solve the problem in English. Completely unambiguously. That's enough for me. Because once you know how to solve it in English, I can tell you how to translate that into Python or Java. And it's a whole lot easier, I can bet, than trying to learn to speak Mandarin or Italian or, you know, some Swahili language. So immediately, you know, it's much easier to learn Java or C++. And I can do that. So I don't care if you don't know the superficial aspects. I just need to know if you know the concept. And that is why you can go to these any of the popular companies, I'm pretty sure. None of them care. I'm pretty sure that about which language you solve things in. And you don't have to even use the whiteboard. You can just sit across from the table and say, this is how I'd solve it. And I'm pretty sure they'll be happy with that kind of conversation. And in fact, that'll be better, because then you sit across the table, you can have a much better conversation with that person too, because you can also find out how people in the company think. Because there's no point in joining a company where, you know, everybody, you don't mentally resonate with the majority of the people. And so you go to a company where you get to interact with at least 4 or 5 different people in one day. And so you can find out. So even if one person is mean, yeah, okay, well, you can try 4 other people, right? And so you have to mentally resonate with at least one. And it's not that, and you can never find that out if you are trying to validate yourself and saying, well, I got to prove myself to that person. And then you're in defensive mode all the time. You never get to peek into what that person is thinking or possible things that, right? And so, and one way to get really comfortable with that is get solid on the material, you know, because then you won't be intimidated. And then you can have a frank one-to-one conversation as a peer. And that way you'll be able to dive into each other's minds much better. And when you dive into each other's minds, and you've dived into 5 or 10 other people's minds, right? And in the progression of interviews, you'll know exactly the kind of people that you're going to be interacting with. And then when you get the offer, you can make a conscious decision and say, okay, well, you know what? Here's where I think there's a lot of people who are willing to teach me new things. And here's maybe there's more people that want to keep good things to themselves, right? Interesting things they do, they won't share. Right, so here I might have a much better time. And so all of these things, right? And this, you know, and the likelihood of diversifying into that area, which I think this can be repurposed in, greater likelihood with this company, right? Whereas here the focus is, you know, XYZ. So how well you won't even get to making these decisions if we're just focused on how do I get into this company in that group. And so by mastering the material, you can just go and evaluate where you want to go rather than letting yourself be evaluated by other people. Yeah, I don't know if that was useful, you know, but you know, it is an informal off-class meeting essentially, right? So we're just, you know, talking frankly, and you know, these are just opinions of mine, so it may not even be true tomorrow. So
No, I think it's really interesting, sort of what to focus on and what matters in sort of the job.
it's just my perspective, right? So
your
just,
informed opinion with 20 years of experience. So that's more informed than most of
I can definitely
opinions
remember
out
when I
there.
was your age, okay? So yeah, because you know, there's some part of you that you don't remember. As you get older, well, you actually, I remember everything, mostly, I think. But I think at some point, some of the earlier times in my life, I couldn't remember. Now I can remember everything. But at some point, I was just blanking out on certain very early parts of my childhood and all. But I think that kind of moves. Maybe when I'm much older, I'll start forgetting them again. But certainly I can remember. Yeah, I don't know how I started talking about them. So. I'm sorry, did I just butt into your conversation? You know, because
No,
I
we
remember
asked
that I
you.
turned
We
the laptop
asked you a
around and then
question.
Eileen called me back. And then I just hijacked the whole damn thing from there. I'm sorry, okay? I'm just gonna turn the laptop around. If you gotta go, fine, no worries, okay? But the whole
No, we
idea of
called
this.
you over, so you were invited to answer the questions.
Okay, all right, so all right. Okay.
You like don't
Okay,
remember.
good to
but-
know, thank you. But don't call me over
Um,
unless, yeah.
No, I
feel
think
free
that
to
was
talk.
valuable. I think that was valuable because we were trying to answer questions ourselves and we were like, we don't know, so we should ask.
Oh, did I answer your question? Well, I think it was about which language is better or something like that.
Yeah, just
Colin
like
asked
comparing
that
and contrasting languages and also
Yeah, I don't know. I just use
Interesting
whatever's
stuff.
available, and you know, yeah.
Yeah, I
You want me
think
to turn it
that's
around?
all. But thank you guys for sharing.
Oh,
this
shall we just call it
information.
a day and end the meeting right now, so I don't have to come back and all?
I think we're good. I think we talked about everything we wanted to talk about.
Awesome. So
Yeah.
we'll meet again next week, I guess. Is there one more
Yeah,
meeting?
last one next
Okay.
week.
Awesome. Oh, next week is week 6, is it? That next week is the week of the final? No, I can't.
Week 5 and then week 6 is,
Oh, okay. So that's not the week of the
Yeah.
final. So there's one more after that.
yeah. Okay.
Awesome.
Thank you.
All right. Good luck with everything, and
Bye,
I'll see you
guys.
guys next week. Bye.